Logan, you're gonna have to get like a pressure washer for that, dude.
Only got all these
Alright. In the next section here, we are going to talk about matrix inverses. Matrix inverses. So, if we recall what an inverse is, okay, a multiplicative inverse. If we recall what a multiplicative inverse is, okay, it's something, okay, that when I multiply by the inverse, so here's my number and here's its inverse, I get 1. Okay, that's what a multiplicative inverse is. For example, 7 times 1/7 is 1. So 7 and 1/7 are multiplicative inverses. Okay? We want to apply that idea to matrices today. So a matrix inverse, okay, is if I have two matrices multiplied together, we get what's called the identity matrix. Okay? If we're talking about just numbers, 1 is the multiplicative identity. If we're talking about matrices, okay, the identity matrix is the matrix that has 1s in all of the diagonals, or in all entries in the diagonal, and 0s everywhere else. Okay, so if we're talking about a 2x2 matrix, that would just look like this. Right? If we're talking about a 3x3 matrix, say I equals this. If we're talking about a 3x3 matrix, the identity matrix would be this. Okay, if we're talking about a 4x4, right, it'd be the same idea. 1s in the main diagonal and 0s everywhere else. So the inverse of a matrix, so if A is my matrix, its inverse is whatever matrix gets me to this point when I multiply them together. Whenever I multiply a matrix and its inverse, I get the identity matrix. Okay, and that's what this box is essentially saying. So, if we want to determine whether two matrices are inverses of each other, okay, we want to multiply them together and see if we get the identity matrix. So let's try that here. Okay, I've got matrix A and matrix B. So first, I want to multiply A times B. So, to do that multiplication, okay, this is what we just practiced. I'm going to multiply the first row by the first column. So 1 times 7 is 7, and then 3 times -2 would be -6. Then to get, I'll do this entry next, I guess. Second row, first column. 2 times 7 is 14, plus 7 times -2 is -14. Then, to get these entries over here, first row times the second column, so 1 times -3 is -3, plus 3 times 1 is 3. And the final entry will be second row, second column. So 2 times -3 is -6, plus 7 times 1. So this ends up working out to 1, 0, 0, 1. Okay. For this to work, though, okay, we would have to get the identity matrix going both ways. A times B and B times A. If you remember from the notes in the last section, multiplication on matrices is not commutative. So we're not guaranteed to get the same thing multiplying A times B and B times A. If two matrices are inverses, though, we will get the same thing. We'll get the identity matrix. So go ahead and try B times A. Okay, so we should end up with 1, 0, 0, 1 when we multiply b times a. Right? So that means that these two matrices are inverses of each other. When I multiply them together, I get the identity matrix. Right? Questions so far? All right, so let's talk about finding an inverse of a matrix then. Right? So we want to find the inverse of this matrix by writing the identity matrix next to A. So what that's going to look like. Okay, I'm going to take my 1, 2, 3, 5, and then I'm going to write the identity matrix over here. Okay. So now, what I want to do is reduce this matrix to row echelon form, okay, which is the identity matrix, 1, 0, 0, 1, using our row operations. As I'm doing that, okay, I'm going to use those same operations over here. And when I'm finished, this will be the inverse matrix. Okay? This is a lot easier with a 2 by 2 than a 3 by 3. Okay? So our goal is just to get zeros here and here, and then ones here and here, using row operations. So let's say I want to get a 0 here first. Well, I would just need to multiply -3 times this row and add it to this row. So I'm going to do -3 times row 1 and add that to row 2. I'm going to put that in place of row 2. So I'm doing that all the way across. Okay, so -3 times 1 is -3 plus 3 will get me 0. I guess I can rewrite my first row in first, so I'm not changing that. Now, -3 times 2 is -6 plus 5 is -1. Then we have -3 plus 0 would be -3. And -3 times 0 is still 0 plus 1 is 1. Okay. So now, try to get a 0 here. Well, if I just multiply the second row by 2 and add that to the first row, I'll get a 0 here. And so I'm going to put that in place of the first row. Okay?
Oh, wait, never mind. Sorry, I was confused.
Yep. All right, so I'm doing -2, or I'm sorry, not -2, +2 times row 2 plus row 1, and I'm putting that in place of row 1 now. So 2 times 0 plus 1 is still 1. 2 times -1 is -2 plus 2 is 0. -6 plus 1 would be -5. And then 2 plus 0 is 2, and then I'm not changing the second row. So 0, -1, -3, 1. Well, the only thing left to do to get positive 1s in the diagonal here would be to multiply this row by -1. So I'm going to do -1 times row 2, put that in place of row 2. So now we end up with 1, 0, 0, 1 here. -5 and 2, and then +3 and -1. This is my inverse matrix. Okay. So if this is A, we can say that A inverse, okay, this is our notation for the inverse, is equal to -5, 2, 3, -1. crazy.
Do you remember when we started doing operations for matrices? Is the very first thing we did? I did.
What are you talking about? Solving
Yeah.
a system?
Yes.
Yes.
Are we gonna really have to do that on the test?
Solve a system?
Yeah. Am I allowed to cry during the test?
Yeah.
Okay. Well, then
Crying is encouraged.
Oh, it is?
Yes.
Well,
Any questions on finding the inverse of a matrix using this method?
that was my question. Do you have an answer?
7. Alright, so we have a shortcut for finding the inverse of a 2 by 2 matrix. Okay, now, this shortcut could be a little challenging to remember. Right? So if you don't remember the shortcut, you can always use the method that we just talked about. But this is our shortcut. Okay? If I have some matrix with entries A, B, C, and D, first of all, it only has an inverse if when I multiply A times D, B times C, and subtract them, that's not 0. Okay? That combination, A times D minus B times C, cannot be 0. Then the inverse has to equal this. Okay? 1 over A times D minus B times C. And then I'm just switching these two entries. So A goes here, D goes up here. And then I'm just taking the opposite of both of these. Those don't switch. Right? So if I'm looking at my original matrix, I switch these two entries in the diagonal, and I just take the opposite of these. And then I'm multiplying that whole thing by 1 over A times D minus B times C. Okay? So let's try one together here. So if I take this matrix here, okay, and I flip 3 and 5, take the opposite of 2 and 4. And then I need to multiply that whole thing by 1 over A times D minus B times C. Okay, so here, that would be 1 over A times D is 15 minus 8. So I'm multiplying that whole thing by 1/7. Okay? So if I'm multiplying each of these entries by 1/7, this is going to end up being 3/7, -4/7, -2/7, 5/7. Okay, so this shortcut is just switch entries A and D, take the opposite of B and C, and then multiply the whole thing by 1 over AD minus BC. Questions?
So that's the inverse.
So this would be the inverse. I guess I should have put a inverse there.
Wow.
That would be the inverse. Okay. Do we want to do another one together or try a couple? All right, let's try a couple.
many things are we doing? We're doing multiple ones.
Yeah, go ahead and try C and D.
Oh, shoot.
There's no way we can do this. It's not possible.
Mr. Fetch, you know what I'm looking forward to? Christmas season. I love Christmas music.
When you start listening to Christmas music.
I don't know, basically whenever everyone else does. I mean, I guess like I don't really put it on the radio myself too often. It's mainly like whenever the fam starts breaking out the regular Christmas songs and the CDs we got.
All right, did we get these answers up here? Okay, for C, we don't have an inverse because A times D is 12 and B times C is 12. So we would get 0 if I do AD minus BC. Okay. Questions on the shortcut here? All right, so let's talk about.
What would happen if you tried to do C without the shortcut?
Oh, that's a good question. So we would end up with
Same answer we got before.
we would end up with something like that, where we could not make this a 1. There would be no way to turn this into the identity matrix. All right, so let's talk about the same things here with a 3x3 matrix. Okay, so first, verifying that two matrices are inverses of each other by multiplying them together. Okay, so if I do this, I should get the 3x3 identity matrix for both of these. Okay, so if I'm multiplying A times B, and I'm going to get, that means I'm multiplying this whole row times this whole column here. Right? So 1 times 3 is 3, 2 times 1 is 2, negative 2 times 2 is negative 4. So that's my first entry. Then first row, second column, 1 times 2 is 2, plus 2 times 1 is 2. Negative 2 times 2 is negative 4. Then, first row, third column, 1 times 6 is 6, plus 2 times 4, I'm sorry, 2 times 2 is 4, and then minus 10. So, now second row, first column, negative 1 times 3 is negative 3. 3 times 1 is 3. 0 times 2 is 0. Second row, second column. -1 times 2 is -2. 3 times 1 is 3. 0 times 2 is 0. Second row, third column. -1 times 6 is -6. 3 times 2 is 6. 0 times 5 is 0. Then finally, our third row entries. So third row, first column, 0 times 3 is 0. -2 times 1 is -2. 1 times 2 is 2. Third row, second column, 0 times 2 is 0. -2 times 1 is -2. 1 times 2 is 2. And our final entry, third row, third column, 0 times 6 is 0. -2 times 2 is -4. 1 times 5 is 5. So all of this ends up getting me 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? So multiplying A times B, we get the identity matrix. Okay? We're running a little bit short on time, so we'll skip going the other way, but we will get the same thing. We will get the identity matrix if we multiply B times A.
That's freaking crazy, dude.
Okay. So the last thing that I want to show you is finding inverses using a calculator. Okay, so if you have a calculator, get it out. If you don't, grab one.
You're gonna hear from BPA from the class. Said we get 90 minutes. Said we do it at the very beginning of class. We kept making impersonations of and he was like, I don't need to say that.
All right, on your calculators, there is a matrix spot right here. Okay, if you hit second and then the inverse button here, it brings up a matrix menu. Okay, so to input a matrix, we need to go over to the edit spot. So I'm going to go over to edit, and I'll just edit the first one. So I'll hit enter on A, and it asks me what dimensions I want my matrix to be. So if we're going to do the first one here, it's a 2 by 2. So I'm going to do 2, enter 2. It gives me a 2 by 2 matrix. Now I can input this matrix. So -2, 2, -9, 8. Okay, so we have our matrix in our calculator. So now we need to go back to the matrix menu. So I'm just going to hit second matrix again. And now it shows me that I have a 2 by 2 matrix entered in for A. If I want to find the inverse, I'm just going to hit enter on that. And it's going to, oops, was I under, oh shoot, I was. I need to quit that and then go to matrix. So if I hit enter, now it brings me to the home screen and puts matrix A up on the home screen. To find the inverse, I'm just going to press this inverse button. Okay, the same button that we pressed for the matrix. I'm just not going to hit second this time. Okay, so we should have something that looks like this.
Second.
So if you just hit enter on it, it should bring it up on the home screen. So go over to edit.
Is there a way to do that old stuff on the calculator too? You know, that crazy stuff? Nobody knows how to do?
Maybe.
Maybe as in like there is and you're just not going to tell us, or maybe as in you don't know?
Maybe.
Got him.
Okay. So once we get our matrix on the home screen, the inverse button is that same button as the matrix button. We just don't hit second. So if you notice, this is the same example as D, the one that we did above. Okay, and we get this answer that we got without using the calculator. Okay? So we can use the calculator to find inverses. Questions? Okay, why don't you guys try the last one then? Okay, input a 3x3 matrix in, and then find the inverse.
Maybe I will. It's pretty nifty, Mr. Chad.
Seriously? That anyone get on stage at all? How are you getting beat by an office bro?
How are you in computer science class?